Item 420. Concrete substructures. 1. Description. Construct concrete substructures including footings, columns, caps, abutments, piers, culverts, other bridge substructure elements, and other concrete structures as indicated. 2. Materials. 2.1 Concrete. Provide concrete in accordance with Item 421, hydraulic cement concrete. Provide the class of concrete for each type of structure or unit as shown on the plans or in pertinent governing specifications. 2.2 Grout or mortar. Provide grout for doweling anchors or precast connections in accordance with DMS 4675, cementitious grouts and mortars for miscellaneous applications. 2.3 Latex curing materials. Provide an acrylic polymer latex admixture, acrylic resin emulsion per DMS 4640, chemical admixtures for concrete, suitable for producing polymer modified concrete or mortar. Do not allow latex to freeze. 2.4 Reinforcing steel. Provide reinforcing steel in accordance with Item 440, reinforcement for concrete. 2.5 Expansion joint material. Provide materials in accordance with DMS 6310, joint sealants and fillers. Provide preformed fiber expansion joint material that conforms to the dimensions shown on the plans. Provide preformed bituminous fiber material unless otherwise specified. Provide asphalt board that conforms to dimensions shown on the plans. Provide rebonded neoprene filler that conforms to the dimensions shown on the plans. 2.6 Water stop. Provide rubber or polyvinyl chloride, PVC, water stops in accordance with DMS 6160, water stops, nylon reinforced neoprene sheet, and elastomeric pads, unless otherwise shown on the plans. 2.7 Curing materials. Provide membrane curing compounds in accordance with DMS 4650, hydraulic cement concrete curing materials and evaporation retardants. Provide cotton mats that consist of a filling material of cotton bat or bats, at least 12 ounces per square yard, completely covered with unzized cloth, at least 6 ounces per square yard, stitched longitudinally with continuous parallel rows of stitching spaced at less than 4 inches, or tufted both longitudinally and transversely at intervals less than 3 inches. Provide cotton mats that are free from tears and in good general condition. Provide a flap at least 6 inches wide consisting of 2 thicknesses of the covering and extending along one side of the mat. Provide polyethylene sheeting that is at least 4 mils thick and free from visible defects. Provide only clear or opaque white sheeting when the ambient temperature during curing exceeds 90 degrees Fahrenheit or when applicable to control temperature during mass powers. Provide burlap polyethylene mats made from burlap impregnated on one side with a film of opaque white pigmented polyethylene, free from visible defects. Provide laminated mats that have at least one layer of an impervious material such as polyethylene, vinyl plastic, or other acceptable material, either as a solid sheet or impregnated into another fabric, and are free of visible defects. Provide burlap material which complies with OSHTO M182, Class 3, 10 ounces per square yard, with the following additions. Manila hemp may also be used to make burlap. Do not use burlap fabricated from bags. Do not use burlap containing any water-soluble ingredient which will retard the setting time of concrete. Provide used burlap complying with the requirements stated above and that has only been used previously for curing concrete. Like new, cleanliness is not expected, but contamination with any substance foreign to the concrete curing process, such as grease or oil, will be cause for rejection. 2.8 Epoxy. Provide epoxy materials in accordance with DMS 6100, epoxies and adhesives, unless otherwise specified. 3. Equipment. 3.1 Transporting and placing equipment. Use appropriate transporting and placing equipment such as buckets, chutes, buggies, belt conveyors, pumps, or other equipment as necessary. Ensure concrete is not transported or conveyed through equipment made of aluminum. Use tremies to control the fall of concrete or for underwater placement. Use tremies that are watertight and of large enough diameter to allow the placement of the concrete but less than 14 inches in diameter. Construct the tremie so the bottom can be sealed and opened once the tremie has been fully charged with concrete for underwater placements. Use pumps with lines at least 5 inches inside diameter, ID, where grade 2 or smaller coarse aggregate is used, and at least 8 inches ID for grade 1 coarse aggregate. 3.2 Vibrators. Use immersion type 5 vibrators for consolidation of concrete. Provide at least one standby vibrator for emergency use. Furnish vibrator head covered by a rubberized or elastomeric cover when used near epoxy-coated reinforcing steel. 3.3 Temperature recording equipment. Use strip chart temperature recording devices, recording maturity meters in accordance with TEX 426A, or other approved devices that are accurate to within plus or minus 2 degrees F within the range of 32 degrees Fahrenheit to 212 degrees Fahrenheit for mass concrete operations, cold weather placements, and as otherwise specified. 3.4 Artificial heating equipment. Use artificial heating equipment as necessary for maintaining the concrete temperatures as specified in section 420.4.7.11, placing concrete in cold weather. 3.5 Spraying equipment. Use mechanically powered pressure sprayers, either air or airless, with appropriate atomizing nozzles for the application of membrane curing. Use hand pressurized spray equipment with 2 or 3 fan spray nozzles if approved. Ensure the spray from each nozzle overlaps the spray from adjacent nozzles by approximately 50%. 3.6 Concrete testing equipment. Provide testing equipment for use by the engineer in accordance with section 421.3.3, testing equipment. 4. Construction. Obtain approval for proposed construction methods before starting work. Approval of construction methods and equipment does not relieve the contractor's responsibility for safety or correctness of methods, adequacy of equipment, or completion of work in full accordance with the contract. Unless otherwise shown on the plans, it is the contractor's option to perform testing on structural concrete. Structural classes of concrete are identified in Table 8 of Section 421.4.1, Classification of Concrete Mix Designs, to determine the in situ strength to address the schedule restrictions in Section 420.4.1, Schedule Restrictions. The engineer may require the contractor to perform this testing for concrete placed in cold weather. Make enough test specimens for contractor perform testing to ensure strength requirements are met for the operations listed in Section 420.4.1, Schedule Restrictions. Make at least one set of test specimens for each element cast each day. Cure these specimens under the same conditions as the portion of the structure involved for all stages of construction. Ensure safe handling, curing, and storage of all test specimens. Provide testing personnel and sample and test the hardened concrete in accordance with Section 421.4.8, Sampling and Testing of Concrete. The maturity method, TEX 426A, may be used for in situ strength determination for schedule restrictions if approved. Coring will not be allowed for in situ strength determination for schedule restrictions. Provide the engineer the opportunity to witness all testing operations. Report all test results to the engineer. If the contractor does not wish to perform schedule restriction testing, the engineer's 7-day lab cured tests, performed in accordance with Article 421.5, Acceptance of Concrete, will be used for schedule restriction determinations. The engineer may require additional time for strength gain to account for field curing conditions such as cold weather. 4.1 Schedule Restrictions. Construct and open completed structures to traffic with the following limitations unless otherwise shown on the plans. 4.1.1 Setting Forms. Attain at least 2,500 psi compressive strength before erecting forms on concrete footings supported by piling or drilled shafts, or on individual drilled shafts. Erect forms on spread footings and culvert footings after the footing concrete has aged at least 2 curing days as defined in section 420.4.10, curing concrete. Place concrete only after the forms and reinforcing steel have been inspected by the engineer. Support tie beam or cap forms by false work on previously placed tie beams only if the tie beam concrete has attained a compressive strength of 2,500 psi and the member is properly supported to eliminate stresses not provided for in the design. Maintain curing as required until completion of the curing period. Place superstructure forms or false work on the substructure only if the substructure concrete has attained a compressive strength of 3,000 psi. 4.1.2 Removal of forms and false work. Keep in place weight supporting forms and false work for bridge components and culvert slabs until the concrete has attained a compressive strength of 2,500 psi in accordance with section 420.4.11, removal of forms and false work. Keep all forms for mass placements in place for 4 days following concrete placement unless otherwise approved based on the outcome of the heat control plan outlined in section 420.4.7.14, mass placements. 4.1.3 Placement of superstructure members. Erect or place superstructure members or precast substructure members only after the substructure concrete has attained a compressive strength of 3,000 psi. 4.1.4 Opening to traffic. Direct traffic culverts may be opened to construction traffic when the design strength specified in section 421.4.1, classification of concrete mix design, has been attained if curing is maintained. Obtain approval before opening direct traffic culverts to the traveling public. Open other non-critical structural and non-structural concrete for service upon the completion of curing unless otherwise specified or directed. 4.1.5 Post-tensioned construction. Ensure strength requirements on the plans for structural elements designed to be post-tensioned are met for stressing and staged loading of structural elements. 4.1.6 Backfilling. Backfill in accordance with section 400.3.3, backfill. 4.2 Plans for false work and forms. Submit plans for false work and forms for the following items: vertical forms for piers and single column bands, load supporting forms for caps and tie beams, form attachments for bridges to be widened, and other items as indicated or directed. Provide design calculations when requested. Show all essential details of proposed forms, false work, and bracing. Have a licensed professional engineer design, seal, and sign these plans. Department approval is not required, except as noted in Table 1 of Item 5, Control of the Work, when forms or false work are located such that public safety can be affected, but the department reserves the right to request modifications to the plans. The contractor is responsible for the adequacy of these plans. Design job fabricated form work assuming a weight of 150 pcf for concrete, and include a live load allowance of 50 psf of horizontal surface of the form. Do not exceed 125% of the allowable stresses used by the department for the design of structures. 4.3 False work. Design and construct false work to safely carry the maximum anticipated loads, including wind loads, and to provide the necessary rigidity. Consult OSHTO's Guide Design Specifications for Bridge Temporary Works and Construction Handbook for Bridge Temporary Works for false work and shoring information not indicated below. Submit details in accordance with Section 420.4.2, Plans for False Work and Forms. Design job fabricated false work assuming a weight of 150 pcf for concrete, and include a minimum live load allowance of 50 psf of horizontal surface of the form. Do not exceed 125% of the allowable stresses used by the department for the design of structures. Do not exceed the manufacturer's maximum allowable working loads for moment and shear or end reaction for commercially produced structural units used in false work. Include a minimum live load allowance of 35 psf of horizontal form surface in determining the maximum allowable working load for commercially produced structural units. Provide timber that is sound, in good condition, and free from defects that would impair its strength. Provide timber that meets or exceeds the species, size, and grade requirements in the submitted false work plans. Provide wedges made of hardwood or metal in pairs to adjust false work to desired elevations to ensure even bearing. Do not use wedges to compensate for incorrectly cut bearing surfaces. Use sills or grillages large enough to support the superimposed load without settlement. Take precautions to prevent settling of the supporting material unless the sills or grillages are founded on solid rock, shale, or other hard materials. Place false work that cannot be founded on a satisfactory spread footing on piling or drilled shafts with enough bearing capacity to support the superimposed load without settlement. Drive false work piling to the required resistance determined by the applicable formula in item 404, driving piling. Design drilled shafts for false work to carry the superimposed load using both skin friction and point bearing. Weld in conformance with item 448, structural field welding. Securely brace each false work bent to provide the stiffness required, and securely fasten the bracing to each pile or column it crosses. Remove false work when it is no longer required or as indicated on the submitted false work plan. Pull or cut off foundations for false work at least 2 feet below finished ground level. Completely remove false work, piling, or drilled shafts in a stream, lake, or bay to the approved limits to prevent obstruction to the waterway. 4.4 Forms. Submit formwork plans in accordance with section 420.4.2, Plans for false work and forms. 4.4.1 General. Provide forms of either timber or metal except where otherwise specified or permitted. Design forms for the pressure exerted by a liquid weighing 150 pcf. Take the rate of concrete placement into consideration in determining the depth of the equivalent liquid. Include a minimum live load allowance of 50 psf of horizontal surface for job fabricated forms. Do not exceed 125% of the department's allowable stresses for the design of structures. Do not exceed the manufacturer's maximum allowable working loads for moment and shear or end reaction for commercially produced structural units used for forms. Include a minimum live load allowance of 35 psf of horizontal form surface in determining the maximum allowable working load for commercially produced structural units. Provide steel forms for round columns unless otherwise approved. Refer to item 427, Surface finishes for concrete, for additional requirements for off-the-form finishes. Provide commercial form liners for imprinting a pattern or texture on the concrete surface as shown on the plans and specified in section 427.4.3.5, Form liner finish. Provide forming systems that are practically mortar-tight, rigidly braced, and strong enough to prevent bulging between supports, and maintain them to the proper line and grade during concrete placement. Maintain forms in a manner that prevents warping and shrinkage. Do not allow offsets at form joints to exceed 1/16 inches. Use only material that is inert, non-biodegradable, and non-absorptive for forms to be left in place. Construct all forms to permit their removal without marring or damaging the concrete. Clean all forms and footing areas of any extraneous matter before placing concrete. Provide openings in forms if needed for the removal of lead ants or foreign matter. Treat the facing of all forms with bond-breaking coating of composition that will not discolor or injuriously affect the concrete surface. Take care to prevent coating of the reinforcing steel. Complete all preparatory work before requesting permission to place concrete. Cease placement if the forms show signs of bulging or sagging at any stage of the placement, and remove the portion of the concrete causing this condition immediately as directed. Reset the forms and securely brace them against further movement before continuing the placement. 4.4.2 Timber forms. Provide properly seasoned, good quality lumber that is free from imperfections that would affect its strength or impair the finished surface of the concrete. Provide timber or lumber that meets or exceeds the requirements for species and grade in the submitted formwork plans. Maintain forms or form lumber that will be reused so it stays clean and in good condition. Do not use any lumber that is split, warped, bulged, or marred, or that has defects in any way that will produce inferior work. Promptly remove such lumber from the work. Provide form lining for all formed surfaces except the inside of culvert barrels, inlets, manholes, and box girders. Surfaces that are subsequently covered by backfill material or are completely enclosed, and any surface formed by a single finished board or by plywood. Provide form lining of an approved type such as masonite or plywood. Do not provide thin membrane sheeting such as polyethylene sheets for form lining. Use plywood at least 3/4 inches thick. Place the grain of the face plies on plywood forms parallel to the span between the supporting studs or joists unless otherwise indicated on the submitted form drawings. Use plywood for forming surfaces that remain exposed that meets the requirements for BB Pliform Class 1 or Class 1I exterior of the U.S. Department of Commerce Voluntary Product Standard PS1. Space studs and joists so the facing form material remains in true alignment under the imposed loads. Space wales closely enough to hold forms securely to the designated lines, scabbed at least 4 feet on each side of joints to provide continuity. Place a row of wales near the bottom of each placement. Place facing material with parallel and square joints, securely fastened to supporting studs. Place forms with the form panels symmetrical, long dimensions set in the same direction, for surfaces exposed to view and receiving only an ordinary surface finish as defined in section 420.4.13, ordinary surface finish. Make horizontal joints continuous. Make molding for chamfer strips or other uses of materials of a grade that will not split when nailed and can be maintained to a true line without warping. Dress wood molding on all faces. Fill forms at all sharp corners and edges with triangular chamfer strips measuring 3/4 inches on the sides unless otherwise shown on the plans. Use metal form ties of an approved type or a satisfactory substitute of a type that permits ease of removal of the metal to hold forms in place. Cut back wire ties at least 1/2 inches from the face of the concrete. Use devices to hold metal ties in place that are able to develop the strength of the tie and adjust to allow for proper alignment. Entirely remove metal and wooden spreaders that separate the forms as the concrete is being placed. Provide adequate clean-out openings for narrow walls and other locations where access to the bottom of the forms is not readily attainable. 4.4.3 Metal forms. Requirements for timber forms regarding design, mortar tightness, filleted corners, beveled projections, bracing, alignment, removal, reuse, and wetting also apply to metal forms except metal forms do not require lining unless specifically noted on the plans. Use form metal thick enough to maintain the true shape without warping or bulging. Countersink all bolt and rivet heads on the facing sides. Design clamps, pins, or other connecting devices to hold the forms rigidly together and to allow removal without damage to the concrete. Use metal forms that present a smooth surface and line up properly. Keep metal free from rust, grease, and other foreign materials. 4.5 Drains. Install and construct weep holes and roadway drains as shown on the plans. 4.6 Placing reinforcement and post-tensioning. Place reinforcement as provided in item 440, reinforcement for concrete. Do not weld reinforcing steel supports to other reinforcing steel except where shown on the plans. Place post-tensioning ducts, anchorages, and other hardware in accordance with the approved press dressing details and item 426, post-tensioning. Keep ducts free of obstructions until all post-tensioning operations are complete. 4.7 Placing concrete. Give the engineer sufficient advance notice before placing concrete in any unit of the structure to permit the inspection of forms, reinforcing steel placement, and other preparations. Do not place concrete when impending weather conditions would impair the quality of the finished work. Place concrete in early morning or at night or adjust the placement schedule for more favorable weather when conditions of wind, humidity, and temperature are such that concrete cannot be placed without the potential for weather-related distress. Adequately illuminate the entire placement site as approved when mixing, placing, and finishing concrete in non-daylight hours. Furnish adequate shelter to protect the concrete against damage from rainfall or freezing temperatures as outlined in this item if changes in weather conditions require protective measures after work starts. Continue operations during rainfall only if approved. Use protective coverings for the material stockpiles. Cover aggregate stockpiles only to the extent necessary to control the moisture conditions in the aggregates. Allow at least one curing day after the concrete has achieved initial set before placing strain on projecting reinforcement to prevent damage to the concrete. 4.7.1 Placing temperature. Place concrete according to the following temperature limits for the classes of concrete defined in section 421.4.1, Classification of Concrete Mix Designs. Place class C, F, H, K, or SS concrete only when its temperature at time of placement is between 50 degrees Fahrenheit and 95 degrees Fahrenheit. Increase the minimum placement temperature to 60 degrees Fahrenheit if slag cement is used in the concrete. Place class S concrete, used in this item only as indicated for culvert top slabs, only when its temperature is between 50 degrees Fahrenheit and 85 degrees Fahrenheit. Increase the minimum placement temperature to 60 degrees Fahrenheit if slag cement is used in the concrete. Place class A, B, and D concrete only when its temperature at the time of placement is greater than 50 degrees Fahrenheit. Place mass concrete in accordance with section 420.4.7.14, mass placements, only when its temperature at the time of placement is between 50 degrees Fahrenheit and 75 degrees Fahrenheit. 4.7.2 Transporting time. Begin the discharge of concrete delivered in truck mixers within the times listed in Table 14 of Item 421, Hydraulic Cement Concrete. 4.7.3 Workability of concrete. Place concrete with a slump as specified in Section 421.4.2.5, slump. Water may be added to the concrete before discharging any concrete from the truck to adjust for low slump provided that the maximum mix design water-cement ratio is not exceeded. Mix concrete in accordance with Section 421.4.6, mixing and delivering concrete, after introduction of any additional water or chemical admixtures. Do not add water or chemical admixtures after any concrete has been discharged. 4.7.4 Transporting concrete. Transport concrete by buckets, chutes, buggies, belt conveyors, pumps, or other methods. Protect concrete transported by conveyors from sun and wind to prevent loss of slump and workability. Shade or wrap with wet burlap pipes through which concrete is pumped as necessary to prevent loss of slump and workability. Arrange and use chutes, troughs, conveyors, or pipes so the concrete ingredients will not be separated. Terminate such equipment in vertical downspouts when necessary to prevent segregation. Extend open troughs and chutes, if necessary, down inside the forms or through holes left in the forms. Keep all transporting equipment clean and free from hardened concrete coatings. Discharge water used for cleaning clear of the concrete. 4.7.5 Preparation of surfaces. Thoroughly wet all forms and hardened concrete on which concrete is to be placed before placing concrete on them. Remove any remaining puddles of excess water before placing concrete. Provide surfaces that are in a moist, saturated surface dry condition when concrete is placed on them. Ensure the subgrade or foundation is moist before placing concrete on grade. Lightly sprinkle the subgrade if dry. 4.7.6 Expansion joints. Construct joints and devices to provide for expansion and contraction in accordance with plan details. Use light wire or nails to anchor any preformed fiber joint material to the concrete on one side of the joint. Ensure finished joints conform to the plan details with the concrete sections completely separated by the specified opening or joint material. Remove all concrete within the joint opening soon after form removal and again where necessary after surface finishing to ensure full effectiveness of the joint. 4.7.7 Construction joints. A construction joint is the joint formed by placing plastic concrete in direct contact with concrete that has attained its initial set. Monolithic placement means the manner and sequence of concrete placing does not create a construction joint. Make construction joints of the type and at the locations shown on the plans. Additional joints in other members are not permitted without approval. Place authorized additional joints using details equivalent to those shown on the plans for joints in similar locations. Make construction joints square and normal to the forms unless otherwise required. Use bulkheads in the forms for all vertical joints. Thoroughly roughen the top surface of a concrete placement terminating at a horizontal construction joint as soon as practical after initial set is attained. Thoroughly clean the hardened concrete surface of all loose material, lands, dirt, and foreign matter, and saturate it with water. Remove all free water and moisten the surface before concrete or bonding grout is placed against it. Ensure the surface of the existing concrete is in a saturated surface dry condition, SSD, just before placing subsequent concrete. Wet the existing concrete by ponding water on the surface for 24 hours before placing subsequent concrete. Use high-pressure water blasting if ponding is not possible to achieve SSD conditions 15 to 30 minutes before placing the concrete. An SSD condition is achieved when the surface remains damp when exposed to sunlight for 15 minutes. Draw forms tight against the existing concrete to avoid mortar loss and offsets at joints. Bonding agents are not required unless indicated otherwise. Coat the joint surface with bonding mortar, grout, epoxy, or other material if a bonding agent is required as indicated on the plans. Provide Type 5 epoxy per DMS 6100, epoxies and adhesives, for bonding fresh concrete to hardened concrete. Place the bonding epoxy on a clean, dry surface, and place the fresh concrete while the epoxy is still tacky. Place bonding mortar or grout on a surface that is SSD, and place the concrete before the bonding mortar or grout dries. Place other bonding agents in accordance with the manufacturer's recommendations. 4.7.8 Handling and placing. Minimize segregation of the concrete and displacement of the reinforcement when handling and placing concrete. Produce a uniform, dense compact mass. Ensure concrete free falls no more than 5 feet except in the case of drilled shafts, thin walls such as in culverts, or as allowed by other items. Remove any hardened concrete splatter ahead of the plastic concrete. Fill each part of the forms by depositing concrete as near its final position as possible. Do not deposit large quantities of concrete at one point and run or move the concrete along to fill the forms. Deposit concrete in the forms in layers of suitable depth but no more than 36 inches deep unless otherwise permitted. Avoid cold joints in a monolithic placement. Sequence successive layers or adjacent portions of concrete so they can be vibrated into a homogeneous mass with the previously placed concrete before it sets. Allow no more than 1 hour to elapse between adjacent or successive placements of concrete when revibration of the concrete is shown on the plans except as otherwise allowed by an approved placing procedure. This time limit may be extended by January 2 hours if the concrete contains at least the minimum recommended dosage of a type B or D admixture. 4.7.9 Consolidation. Carefully consolidate concrete and flush mortar to the form surfaces with immersion type 5 vibrators. Do not use vibrators that operate by attachment to forms or reinforcement except where approved on steel forms. Vibrate the concrete immediately after deposit. Systematically space points of vibration to ensure complete consolidation and thorough working of the concrete around the reinforcement, embedded fixtures, and into the corners and angles of the forms. Insert the vibrators vertically where possible. Vibrate the entire depth of each lift, allowing the vibrator to penetrate several inches into the preceding lift. Do not use the vibrator to move the concrete to other locations in the forms. Do not drag the vibrator through the concrete. Thoroughly consolidate concrete along construction joints by operating the vibrator along and close to but not against the joint surface. Continue the vibration until the concrete surrounding reinforcements and fixtures is completely consolidated. Hand spade or rod the concrete if necessary to ensure flushing of mortar to the surface of all forms. April 7, 10 Installation of dowels and anchor bolts. Install dowels and anchor bolts by casting them in place or by grouting with grout, epoxy, or epoxy mortar unless noted otherwise. Form or drill holes for grouting. Follow the manufacturer's recommended installation procedures for pre-packaged grout or epoxy anchor systems. Test anchors if required on the plans or by other items. Drill holes for anchor bolts to accommodate the bolt embedment required by the plans. Make holes for dowels at least 12 inches deep unless otherwise shown on the plans. Make the hole diameter at least twice the dowel or bolt diameter, but not exceeding the dowel or bolt diameter plus 1.5 inches when using cementitious grout or epoxy mortar. Make the hole diameter 1/16 to 1/4 inches greater than the dowel or bolt diameter when using neat epoxy unless indicated otherwise by the epoxy manufacturer. Thoroughly clean holes of all loose material, oil, grease, or other bond-breaking substance, and blow them clean with filtered compressed air. Use a wire brush followed by oil-free compressed air to remove all loose material from the holes, repeating as necessary until no more material is removed. Ensure holes are in a surface dry condition when epoxy-type materials are used and in a surface moist condition when cementitious grout is used. Develop and demonstrate for approval a procedure for cleaning and preparing the holes for installation of the dowels and anchor bolts. Completely fill the void between the hole and dowel or bolt with grouting material. Follow exactly the requirements for cleaning outlined in the product specifications for pre-packaged systems. Provide hydraulic cement grout for cast-in-place or grouted systems in accordance with DMS 4675, cementitious grouts and mortars for miscellaneous applications. Provide a Type 1-2 epoxy per DMS 6100, epoxies and adhesives, when neat epoxy is used for anchor bolts or dowels. Provide Type 5-3 epoxy per DMS 6100, epoxies and adhesives, when an epoxy grout is used. Provide grout, epoxy, or epoxy mortar as the binding agent unless otherwise indicated on the plans. Provide other anchor systems as required on the plans. April 7, 11 Placing concrete in cold weather. Protect concrete placed under weather conditions where weather may adversely affect results. Permission given by the engineer for placing during cold weather does not relieve the contractor of responsibility for producing concrete equal in quality to that placed under normal conditions. Remove and replace concrete as directed at the contractor's expense if it is determined unsatisfactory due to poor conditions. Do not place concrete in contact with any material coated with frost or with a temperature of 32 degrees Fahrenheit or lower. Do not place concrete when the ambient temperature in the shade is below 40 degrees Fahrenheit and falling unless approved. Place concrete when the ambient temperature in the shade is at least 35 degrees Fahrenheit and rising or above 40 degrees Fahrenheit. Provide and install recording thermometers, maturity meters, or other suitable temperature measuring devices to verify all concrete is effectively protected as follows. Maintain the temperature at all surfaces of concrete in bends, piers, culvert walls, retaining walls, parapets, wing walls, top slabs of non-direct traffic culverts, and other similar formed concrete at or above 40 degrees Fahrenheit for 72 hours from the time of placement. Maintain the temperature of all other concrete, including the bottom slabs, footings, of culverts, placed on or in the ground above 32 degrees Fahrenheit for 72 hours from the time of placement. Use additional covering, insulated forms, or other means and, if necessary, supplement the covering with artificial heating. Avoid applying heat directly to concrete surfaces. Cure as specified in Section 420.4.10, curing concrete, during this period until all requirements for curing have been satisfied. Have all necessary heating and covering material ready for use before permission is granted to begin placement when impending weather conditions indicate the possible need for temperature protection. April 7, 12 Placing concrete in hot weather. Keep the concrete at or below the maximum temperature at time of placement as specified in Section 420.4.7.1, Placing temperature. Sprinkle and shade aggregate stockpiles or use ice, liquid nitrogen systems, or other approved methods as necessary to control the concrete temperature. April 7, 13. Placing concrete in water. Deposit concrete in water only when shown on the plans or with approval. Make forms or cofferdams tight enough to prevent any water current passing through the space in which the concrete is being deposited. Do not pump water during the concrete placing or until the concrete has set for at least 36 hours. Place the concrete with a tremie or pump, or use another approved method, and do not allow it to fall freely through the water or disturb it after it is placed. Keep the concrete surface level during placement. Support the tremie or operate the pump so it can be easily moved horizontally to cover all the work area and vertically to control the concrete flow. Submerge the lower end of the tremie or pump hose in the concrete at all times. Use continuous placing operations until the work is complete. Design the concrete mix in accordance with item 421, hydraulic cement concrete, with a minimum cement content of 650 pounds per cubic yard for concrete to be placed under water. Include an anti-washout admixture in the mix design as necessary to produce a satisfactory finished product. April 7, 14. Mass placements. Develop and obtain approval for a heat control plan for monolithic placements designated on the plans as mass concrete to ensure the following during the heat dissipation period. The temperature differential between the central core of the placement and the exposed concrete surface does not exceed 35 degrees Fahrenheit and the temperature at the central core of the placement does not exceed 160 degrees Fahrenheit. Use the Concrete Works copyright software available from the department, or another approved method based on the guidelines in ACI 207, Mass Concrete, to develop the heat control plan. The department will make available technical assistance on the use of Concrete Works copyright. Develop the heat control plan using historical temperature ranges for the anticipated time of the mass placement. Recreate the plan if the work schedule shifts by more than 1 month. The heat control plan may include a combination of the following elements. Selection of concrete ingredients including aggregates, gradation, and cement types, to minimize heat of hydration. Use of ice or other concrete cooling ingredients. Use of liquid nitrogen dosing systems. Controlling rate or time of concrete placement. Use of insulation or supplemental external heat to control heat loss. Use of supplementary cementing materials. Use of a cooling system to control the core temperature, or vary the duration formwork remains in place. Furnish and install 2 pairs of temperature recording devices, maturity meters, or other approved equivalent devices. Install devices to measure the surface temperature no more than 3 inches from the surface. Install devices to measure the core temperature a distance of half the least dimension from the nearest surface near the point of maximum predicted heat. Use these devices to simultaneously measure the temperature of the concrete at the core and the surface. Maintain temperature control methods for 4 days unless otherwise approved based on the submitted heat control plan. Do not use maturity meters to predict strength of mass concrete. Revise the heat control plan as necessary to maintain the temperature limitations shown above. If the core temperature exceeds 160 degrees Fahrenheit, the mass concrete element will be subject to review and acceptance by the engineer using forensic analyses to determine its potential reduction in service life or performance. Proceed with subsequent construction on the affected element only when notified regarding acceptance. Repair any resulting cracking if the temperature differential between the central core of the placement and the nearest concrete surface exceeds 35 degrees Fahrenheit at no expense to the department, and revise the heat control plan as necessary to prevent further occurrences. April 7, 15. Placing concrete in foundation and substructure. Do not place concrete in footings until the depth and character of the foundation has been inspected and permission has been given to proceed. Place concrete footings upon seal concrete after the cofferdams are free from water and the seal concrete is cleaned. Perform any necessary pumping or bailing during the concreting from a suitable sump located outside the forms. Construct or adjust all temporary wales or braces inside cofferdams as the work proceeds to prevent unauthorized construction joints. Omit forms when footings can be placed in a dry excavation without the use of cofferdams, if approved, and fill the entire excavation with concrete to the elevation of the top of footing. Place concrete in columns monolithically between construction joints unless otherwise directed. Columns and caps or tie beams supported on them may be placed in the same operation or separately. Allow for settlement and shrinkage of the column concrete, if placed in the same operation, by placing it to the lower level of the cap or tie beam, and delay placement between 1 and 2 hours before proceeding with the cap or tie beam placement. April 7, 16 Placing concrete in box culverts. Allow between 1 and 2 hours to elapse where the top slab and walls are placed monolithically in culverts more than 4 feet in clear height before placing the top slab to allow for settlement and shrinkage in the wall concrete. Accurately finish the footing slab at the proper time to provide a smooth uniform surface. Finish top slabs that carry direct traffic as specified in item 422, concrete superstructures. Give top slabs of fill-type culverts a float finish. 4.8 Extending existing substructures. Verify pertinent dimensions and elevations of the existing structure before ordering any required materials. 4.8.1 Removal. Remove portions of the existing structure to the lines and dimensions shown on the plans or as directed. Dispose of these materials as shown on the plans or as directed. Repair any portion of the remaining structure damaged as a result of the construction. Do not use explosives to remove portions of the existing structure unless approved in writing. Do not use a demolition ball, other swinging weight, or impact equipment unless shown on the plans. Use pneumatic or hydraulic tools for final removal of concrete at the break line. Use removal equipment, as approved, that will not damage the remaining concrete. 4.8.2 Reuse of removed portions of structure. Detach and remove all portions of the old structure that are to be incorporated into the extended structure to the lines and details as specified on the plans or as directed. Move the unit to be reused to the new location specified using approved methods. Place the reinforcement and extension concrete according to the plan details. 4.8.3 Splicing reinforcing steel. Splice new reinforcing bars to exposed bars in the existing structure using lap splices in accordance with item 440, reinforcement for concrete, unless otherwise shown on the plans. The new reinforcing steel does not need to be tied to the existing steel where spacing or elevation does not match that of the existing steel provided the lap length is attained. Weld in accordance with item 448, structural field welding, when welded splices are permitted. Install any required dowels in accordance with section 420.4.7.10, installation of dowels and anchor bolts. 4.8.4 Concrete preparation. Roughen and clean concrete surfaces that are in contact with new construction before placing forms. Prepare these construction joint surfaces in accordance with section 420.4.7.7, construction joints. 4.9 Treatment and finishing of horizontal surfaces. Strike off to grade and finish all unformed upper surfaces. Do not use mortar topping for surfaces constructed under this section. Float the surface with a suitable float after the concrete has been struck off. Slope the tops of caps and piers between bearing areas from the center slightly toward the edge, and slope the tops of abutment and transition bent caps from the back wall to the edge, as directed, so water drains from the surface. Give the concrete a smooth trowel finish. Construct bearing areas for steel units in accordance with section 441.3.11.6, bearing and anchorage devices. Give the bearing area under the expansion ends of concrete slabs and slab and girder spans a steel trowel finish to the exact grades required. Give bearing areas under elastomeric bearing pads or non-reinforced bearing seat buildups a textured, wood float finish. Do not allow the bearing area to vary from a level plane more than 1/16 inches in all directions. Cast bearing seat buildups or pedestals for concrete units integrally with the cap or a construction joint. Provide a latex-based mortar, an epoxy mortar, or an approved proprietary bearing mortar for bearing seat buildups cast with a construction joint. Mix mortars in accordance with the manufacturer's recommendations. Construct pedestals of Class C concrete, reinforced as shown on the plans or as indicated in Figure 1 and Figure 2. The engineer of record will design pedestals higher than 12 inches. Figure 1. Section through bearing seat build-ups. See figure in specifications. Figure 2. Plan view of bearing seat build-ups. See figure in specifications. 4.10 Curing concrete. Obtain approval of the proposed curing methods, equipment, and materials before placing concrete. The engineer may require the same curing methods for like portions of a single structure. Inadequate curing or facilities may delay all concrete placements on the job until remedial action is taken. A curing day is a calendar day when the temperature, taken in the shade away from artificial heat, is above 50 degrees Fahrenheit for at least 19 hours or, on colder days if the temperature of all surfaces of the concrete is maintained above 40 degrees Fahrenheit, for the entire 24 hours. The required curing period begins when all concrete has attained its initial set unless indicated otherwise. TxDOT 440A may be used to determine when the concrete has attained its initial set. Cure all concrete for 4 consecutive days except as allowed for the curing options listed below. Use form or membrane curing for vertical surfaces unless otherwise approved. Use only water curing for horizontal surfaces of HPC or mass concrete. Use water or membrane curing for horizontal or unformed surfaces for all other concrete. Use one of the following curing options for vertical surfaces, unless indicated otherwise. Form cure for 48 hours after placement. Form cure for 12 hours after placement followed by membrane curing. For HPC concrete, form cure for 48 hours after placement followed by membrane curing. For mass concrete, form cure as required by the heat control plan followed by membrane curing if forms are removed before 4 days. Apply membrane curing, if used, within 2 hours of form removal. Use only water curing in accordance with this section for the top surface of any concrete unit upon which concrete is to be placed and bonded at a later interval, stub walls, caps with back walls, risers, etc. Cure all other concrete as specified in the pertinent items. Use the following methods for curing concrete, subject to the requirements of this item. 4.10.1 Form curing. When forms are left in intimate contact with the concrete, other curing methods are not required except for exposed surfaces and for cold weather protection. Use another approved curing method if forms are removed before the 4-day required curing period. 4.10.2 Water curing. Keep all exposed surfaces of the concrete wet continuously for the required curing time. Use water curing in accordance with concrete mixing water in section 421.2.5, water. Do not use seawater or water that stains or leaves an unsightly residue. 4.10.2.1 Blankets. Keep the concrete continuously wet by maintaining wet cotton or burlap mats in direct contact with the concrete for the required curing time. Weight the mats adequately to provide continuous contact with all concrete. Cover surfaces that cannot be cured by direct contact with mats, forming an enclosure well anchored to the forms or ground so outside air cannot enter the enclosure. Provide sufficient moisture inside the enclosure to keep all surfaces of the concrete wet. 4.10.2.2 Water spray. Overlap sprays or sprinklers to keep all unformed surfaces continuously wet. 4.10.2.3 Ponding. Cover the surfaces with at least 2 inches of clean granular material, kept wet at all times, or at least 1 inches deep water. Use a dam to retain the water or saturated granular material. 4.10.3 Membrane curing. Choose either type 1D or type 2 membrane curing compound unless otherwise shown on the plans. Use the same type of curing compound on an individual member. Apply membrane curing just after free moisture has disappeared at a rate of approximately 180 square feet per gallon. Do not spray curing compound on projecting reinforcing steel or concrete that will later form a construction joint. Do not apply membrane curing to dry surfaces. Dampen formed surfaces and surfaces that have been given a first rub so they are moist at the time of application of the membrane. Leave the film unbroken for the minimum curing period specified when membrane is used for complete curing. Correct damaged membrane immediately by reapplication of membrane. Polyethylene sheeting, burlap polyethylene mats, or laminated mats in close contact with the concrete surfaces are equivalent to membrane curing. 4.11 Removal of forms and falsework. Remove forms for vertical surfaces after the concrete has aged a minimum of 12 hours after initial set, provided the removal can be done without damage to the concrete unless otherwise directed. Keep forms for mass placements in place for 4 days following concrete placement unless otherwise approved based on the outcome of the heat control plan outlined in section 420.4.7.14, mass placements. Leave in place weight supporting forms and falsework spanning more than 1 feet for all bridge components and culvert slabs except as directed otherwise until the concrete has attained a compressive strength of 2,500 psi. Remove forms for other structural components as necessary. Remove inside forms, walls and top slabs, for box culverts and sewers after concrete has attained a compressive strength of 1,800 psi if an approved overhead support system was used to transfer the weight of the top slab to the walls of the box culvert or sewer before removal of the support provided by the forms. Forms or parts of forms may be removed only if constructed to permit removal without disturbing forms or falsework required to be left in place for a longer period on other portions of the structure. Remove all metal appliances used inside forms for alignment to a depth of at least 1/2 inches from the concrete surface. Make the appliances so metal may be removed without undue chipping or spalling of the concrete, and so it leaves a smooth opening in the concrete surface when removed. Do not burn off rods, bolts, or ties. Remove all forms and falsework unless otherwise directed. 4.12 Defective work. Repair defective work as soon as possible. Remove and replace at the expense of the contractor any defect that cannot be repaired to the satisfaction of the engineer. 4.13 Ordinary surface finish. Apply an ordinary surface finish to all concrete surfaces. Provide flat or textured surfaces as specified with uniform appearance. Address defects and surface irregularities not consistent with the intent of the expected finish by the following. Chip away all loose or broken material to sound concrete where porous, spalled, or honeycombed areas are visible after form removal. Repair spalls in accordance with the procedures outlined in the concrete repair manual available on the department's website. Clean and fill holes or spalls caused by the removal of form ties, etc., with latex grout, cement grout, or epoxy grout as approved. Fill only the holes. Do not blend the patch with the surrounding concrete. On surfaces to receive a rub finish in accordance with item 427, surface finishes for concrete, chip out exposed parts of metals chairs to a depth of 1/2 inches and repair the surface. Remove all fins, rust staining, runs, drips, or mortar from surfaces that will be exposed. Smooth all form marks and chamfer edges by grinding or dry rubbing. Ensure all repairs are dense, well bonded, and properly cured. Finish exposed large repairs to blend with the surrounding concrete where a higher class of finish is not specified. Apply an ordinary surface finish as the final finish to the following exposed surfaces unless noted otherwise. Inside and top of inlets. Inside and top of manholes. Inside of sewer appurtenances, and inside of culvert barrels. Form marks and chamfer edges do not need to be smoothed for the inside of culvert barrels. 5. Measurement. This item will be measured by the cubic yard, square yard, foot, square foot, or by each structure. 5.1 General. Concrete quantities will be based on the dimensions shown on the plans or those established in writing by the engineer. In determining quantities, no deductions will be made for CHEM FERS less than 2 inches or for embedded portions of steel or pressed rest concrete beams, piling, anchor bolts, reinforcing steel, drains, weep holes, junction boxes, electrical or telephone conduit, ducts, and voids for pressed rest tendons, or embedded portions of light fixtures. Variation in concrete head wall quantity incurred when an alternate bid for pipe is permitted will not be cause for payment adjustment. Quantities revised by a change in design, measured as specified, will be increased or decreased and included for payment. 5.2 Plans quantity. Structure elements designated in Table 1 and measured by the cubic yard are plans quantity measurement items. The quantity to be paid for plans quantity items is the quantity shown in the proposal unless modified by Article 9.2, Plans quantity measurement. Additional measurements or calculations will be made if adjustments of quantities are required. No adjustment will be made for footings or other in-ground elements where the contractor has been allowed to place concrete in an excavation without forms. Table 1. Plans quantity payment. Cubic yard measurement only. Culverts and culvert wing walls. Abutments. Head walls for pipe. Footings. Retaining walls. Pile bent caps. Inlets and manholes. Post-tensioned elements. Note other elements, including pier and bent concrete, may be paid for as plans quantity when shown on the plans. 5.3 Measured in place. Items not paid for as plans quantity will be measured in place. 6. Payment. The work performed and materials furnished in accordance with this item and measured as provided under measurement will be paid for at the unit price bid for the class of concrete and element identified and by the special designation when appropriate. This price is full compensation for furnishing, hauling, and mixing concrete materials, furnishing, bending, fabricating, splicing, welding, and placing the required reinforcement, clips, blocks, metal spacers, ties, wire, or other materials used for fastening reinforcement in place, furnishing, placing, and stressing post-tensioning system, placing, finishing, and curing concrete, mass placement controls, applying ordinary surface finish, furnishing and placing drains, metal flashing strips, and expansion joint material, excavation, subgrade preparation, and forms and false work, equipment, labor, tools, and incidentals. Price will be adjusted in accordance with Article 421.6, measurement and payment when required to address non-compliance of project acceptance testing. Design and installation of foundations for false work is at the contractor's expense. In addition to the work described above, for extending structures the unit prices bid for the various classifications of concrete shown are full compensation for removing and disposing of, if necessary, the designated portion of the existing structure, removing, stockpiling if necessary, and replacing head wall units for reuse, cleaning, bending, and cutting of exposed reinforcing steel, splicing of new reinforcing steel to existing reinforcing steel, installation of dowels, and cleaning and preparing existing concrete surfaces.